Welcome to the session on conditional probability set notation. The objectives for this session are to draw and interpret Venn diagrams and apply the formulae relating to independent and mutually exclusive events. It is possible to use a Venn diagram to represent events graphically. Probabilities or frequencies can be inserted in the regions of the Venn diagram. So S is the sample space, and closed curves in the sample space represent events. Set notation can be used to describe events within this sample space. This helps abbreviate probability statements. So here we have our sample space S. This is the region A intersect B, which means that event A and event B occur. It's also known as the intersection of A and B. If A and B are independent, then probability of A intersect B equals probability of A times probability of B. If A and B are mutually exclusive, then probability of A intersect B equals the empty set. This is the region A union B. It's the event A or the event B. It's also known as the union of A and B. If A and B are mutually exclusive, then probability of A union B equals probability of A plus probability of B. This shaded region is also known as not A. Probability of not A, or A complement, equals 1 minus the probability of A. Events A and A complement are always mutually exclusive. Now pause the video and have a go at this example. Press play when you're ready to view the solutions. So let's solve part A first. In a class of 25 students, 6 are in the football team, 4 are in the tennis team, and 2 are in both the football and the tennis team. A student is chosen at random from the class. Draw a Venn diagram to represent this information. So let's solve this. Here's our sample space S, the class of students. F represents the football team, T represents the tennis team. 2 students are in both the football and the tennis team. Notice that we're starting from the center of the diagram, or the main intersection. So we've inserted 2 right in the intersection. We also have that 4 students are in the tennis team. Therefore, in this shaded region, all the numbers should add up to 4. We already had a 2, now the other number is also a 2. We also know that there are 6 students in the football team. In this shaded region, F, all the numbers should add up to therefore 6. We already have a 2, and therefore we need to add a 4 into the rest of the region in order to make up the 6. And since we have a class of 25 students, we should have 25 students altogether in the sample space. And therefore, there are 17 students who don't play football or tennis. We are required to find the probability of F intersect T. This is of course 2 divided by 25. Now for part C, we are required to find the probability of F union T. This is 4 plus 2 plus 2, which is 8, divided by 25. We are also required in part D to find the probability of not T, so students who don't play tennis. This is equal to 4 plus 17, 21, divided by 25. And in part E, we're required to find the probability of F union T complement. So students who don't play either football or tennis, there are 17 of them, divided by 25. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So here's the scenario. In a survey of 100 people, we have details of how many owned rabbits, cats and fish, and how many owned a combination of them. In order to tackle the questions related to this example, it's always easiest to draw a Venn diagram first. So here's our Venn diagram, currently blank. We have our sample space, and then we've got 3 circles overlapping inside it. One representing the owners of rabbits, another representing the owners of cats, and the third representing the owners of fish. And then we've also got one area shaded. We're going to start creating the Venn diagram or entering the numbers in the Venn diagram from the center. And at the moment we've got the highlighted area representing rabbits, cats and fish. And we've also got that 3 people own rabbits, cats and fish. So the probability of somebody owning rabbits, cats and fish is 3 out of 100, since we have 100 people in the survey. Therefore, we're going to enter 0.03 in the center of the Venn diagram as shown. Notice also that 13 people own cats and rabbits. And therefore, the probability of somebody owning rabbits and cats is 13 out of 100, which is equal to 0.13. So the missing probability in that shaded region is going to be 0.13 minus 0.03, which equals 0.10. And so we enter 0.10 here as shown. There are 16 people who own rabbits and fish. Therefore, the probability that somebody owns rabbits and fish is 16 out of 100, which is equal to 0.16. This is represented by the shaded region in the Venn diagram. However, as we already have 0.03 already in that shaded region, we need to subtract that in order to find the remaining probability. So 0.16 minus 0.03 is equal to 0.13, and we can now enter that also in the Venn diagram. And so we've entered 0.13 in the Venn diagram also. And now for fish and cats. There are 5 people who own fish and cats. Therefore, the probability is 5 out of 100, which equals 0.05. And therefore, the missing probability is 0.05 minus 0.03, which equals 0.02. And we've entered that here. There are 47 people who own fish. Therefore, the probability that somebody owns fish is 47 out of 100, which is 0.47. The total in the shaded region should now equal 0.47. So the missing probability in that shaded region is equal to 0.47 minus the sum of all the other probabilities that are already there, namely 0.03 plus 0.13 plus 0.02. And this calculation equals 0.29. So we now enter 0.29 as shown in the diagram. There are 39 people who own cats. Notice the cat circle has now been highlighted. The probability, therefore, that somebody owns a cat is 39 out of 100, which equals 0.39. In other words, the missing probability in that circle is going to be 0.39 minus the sum of all the other probabilities in that shaded circle, which is 0.39 minus 0.10 plus 0.03 plus 0.02, which equals 0.24. So we enter 0.24 in the diagram as shown. Now for the rabbits. There are 35 people who own rabbits. So the probability that somebody owns a rabbit is 0.35, and therefore the missing probability in the shaded circle is 0.35 minus the sum of the other probabilities, which is this. And calculating this gives us 0.09. So we enter 0.09 in the circle as shown. Now, since the survey consists of 100 people, and we know that the sum of the probabilities so far is the sum of all these numbers in the Venn diagram, we know that the missing probability is going to be 1 minus the sum of all these probabilities, as shown here. And this equals 0.10. So let's pop 0.10 into the diagram as shown, in the sample space, but not in any of the circles. Now we can have a go at part A. A person is chosen at random. Find the probability that the person owns only rabbits. The shaded region represents the people who own only rabbits, and therefore the probability is 0.09. Now for part B. A person is chosen at random. Find the probability that the person does not own cats. This shaded region consists of all the people who don't own cats, and therefore we add up all the probabilities in that shaded region to find the probability that somebody doesn't own a cat. And this probability equals 0.61. Now for part C. A person is chosen at random. Find the probability that the person does not own rabbits, cats, or fish. In other words, the probability must lie in this shaded region, as shown here. This probability is 0.10. Now let's take a look at another example. Using the Venn diagram on your screen, find the probability of F intersect R' union C. So let's look at this stage by stage. Here we have R' or R complement. F intersected with R complement is this shaded region. And so the probability of F intersect R complement is 0.29. Now this shaded region represents F intersect R' union C. And therefore, the probability of F intersect R' union C is the sum of all the probabilities in this shaded region, as shown here, to give us 0.66 as shown. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. In this example, we suppose that A and B are independent events with probability of A equals 0.3 and probability of B equals 0.5. We are required to find the probability of A intersect B. Now, since A and B are independent events, we have probability of A intersect B equals probability of A times probability of B. Therefore, all we need to do is simply plug in the figures. And so we have 0.3 times 0.5. Giving us that the probability of A intersect B is 0.15. And now for the next example. Suppose that A and B are mutually exclusive events with probability of A equals 0.2 and probability of B equals 0.1. We are required to find the probability of A union B. So let's solve this. Since A and B are independent events, we have probability of A union B equals probability of A plus probability of B. And so we simply need to plug in the figures. 0.2 plus 0.1, giving us that the probability of A union B equals 0.3. This brings us to the end of this session. If you have understood its contents, you should be able to draw and interpret Venn diagrams and apply the formulae relating to independent and mutually exclusive events. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.